Let me bring the idea of instantaneous center everything. Determine the distance moved by the lower end at which rod no longer touches the vertical wall. Obtain an expression for the angular velocity of the rod as a function of theta. I think if you recollect, so about what point the rod will rotate. You can, so this is IAOR, this is the center of mass. There's the NA and NB, and let this be R. So we know this distance coordinates of center of mass will be L by 2 cos theta, L by 2 sin theta. We can write all that one. So what can be the distance R? R should be the length of the rod is given, no? Yeah, capital L. Okay, I'll just give 2 minutes time. You have to analyze once, huh? Then I'll come into picture. You have to think. So this is something very important, no? So usually first you do for rod, no? Once you are familiar with the rod, you can proceed for next any other thing. So why that IAO I brought there? So if you see the velocity of NB like this, velocity of NA will be like this. Then what we do? Let me start like this. So this from the air, I'll project the or say I'll produce the radius vector or position vector. From here, the position where these two position vectors intersect, that should be the instantaneous axis of rotation. Okay, fine. That is C is the center of mass. IAOR I should call that one. So if you want, you can give some point P. What is P? P is the instant axis of rotation. P is the what happened? Instantaneous center. Okay, these terms, no, what are P and C will define them. C is the center of mass. Okay, no, let it be. From where this it will get angular velocity. Initially, the rod was vertical, no. So center of mass was at L by 2. Now this rod, let it make an angle theta. So what is the distance of this center of mass? No, will be L by 2 sine theta. Earlier the rod was vertical. So for your convenient, you can have like this. This was the end A. This was the end B. So the center of mass was somewhere here at a distance L by 2. How much it has descended center of mass? It has descended by h. So decrease in gravitational potential G of the rod is got converted into the rotational kinetic energy about point P. So first thing we'll write it, mgh should be equal to ip omega square by 2. mg L by 2 1 minus sine theta. ip by 2 omega square. No. What is the IP? No. So for IP, I need ICZ or IPZ, or it is understood perpendicular to plane. No? So IC plus MR square, where R is the distance from P and C. Parallax theorem I applied. What is IC? IC we are very sure. What is R I should write? I think R should be L by 2. So this will become like a, so what is this length will be? L by 2 sine theta. What is this? L by 2 cos theta. This is L. So what is this length? L by 2 sine theta. This L by 2 cos theta. So therefore this should be the diagonal. Then this should be the off of the diagonal. So therefore R should be L by 2. Okay, think on it. So I got the value of IP. Substituting the value of IP, this will become ml square by 3. The value of IP. This value of IP I'll substitute in this equation. mgl by 2 1 minus sine theta ml square of into 3 omega square. So omega is equal to 3g by L 1 minus sine theta. What is asking? Obtain the expression for the angular velocity of the rod as a function of theta. Okay, this is one equation what we got over. So further, if you want to take under root of it, better do remember this is standard data. If you have a formula book and if you have taken the printout of that, then you enter these things in exam. No, why you should do all this? You can directly start from this question. So like this is standard data. Please do remember angular velocity. Now he's asking, determine the distance moved by the lower end at which the rod no longer touches the vertical wall. Let's do one thing. We'll calculate the angular acceleration. So let me differentiate this with respect to time. So this equation, let me differentiate with respect to time. I'll begin the next part of our discussion. I'll give explanation why the end A will lose contact at one specific angle. That angle is what he's asking. Am I right? So let me differentiate this with respect to time. D omega by dt. 3gl minus 3gl cos theta d theta. D theta by dt is what? Omega. So this will be 3gl by 3g by 2l cos theta. Now what is this? This is the angular acceleration of the rod, alpha. So what do you mean by negative sign? Theta decreases. That's the purpose of. What is the x coordinate of center of mass? So x should be equal to L by 2 cos theta. I'll differentiate this with respect to time twice. Then I'll get x component of acceleration. Dx by dt should be equal to L by 2 minus sin theta d theta by dt. Once again, let me differentiate. L by 2 sin theta d omega by dt. This will become minus L by 2 sin theta alpha L by 2 omega square cos theta. No, let's get into condition. Lower end at which the rod no longer touches the vertical wall. If it doesn't touches the vertical wall, there won't be normal contact. There won't be any force. There won't be any normal contact by the wall on the end A of the rod. So what should be the acceleration AX? Must be 0. Means what happened to normal reaction at the end A will keep on decrease. At one instant, it will become 0. When it becomes 0, there won't be normal contact. There won't be normal. There won't be acceleration AX. This idea. See himself in the question he has given that it will lose contact. Or get an expression for normal contact, you can see that it will decrease with the time. or like as theta decreases, n will decrease or na will decrease. Okay, there's the initial derivation part. I'll proceed now, the theoretical one. The rod will lose contact. The end A of the rod, I'll write. End A of rod will lose contact with the vertical wall at the instant. Let me just indicate NA at the instant NA tends to 0 or NA equal to 0. If NA is 0, then acceleration NX shall I write? NX 0, then AX must be 0. Okay, that I'm going to put a condition. Do we know alpha? Yes, I know alpha. That's why we brought all these things is to take care about these conditions. Okay, let me substitute all these things in this equation. Let me get into this one. AX will be 0. 0 equal to minus L by 2 sine theta. Alpha is minus 3G 2L cos theta. Omega square, no? In place of omega square will be 3G by L 1 minus sine theta. Anybody value theta? We have to calculate sine theta, no? Cos theta also will get eliminated. Anybody value sine theta? Anybody value sine theta? L by 2, so like a 3G by 4 or 3G by 2L will get eliminated, no? Or 3G by 2 will 3G by 2 cos theta will get eliminated. So only sine theta terms will be there. Sine theta, okay, 2 by 3, fine, yeah. When the rod makes an angle theta, sine inverse of 2 by 3 to lose contact. Okay, we got this one. Is asking determine the distance moved by the lower end at which the rod no longer touches the vertical wall. What do you mean by the distance moved by it? I think we should calculate the distance, this particular OB. What is OB should be equal to L cos theta. And we know sine theta. There's only condition here, no? I think I can make things small here. Yeah, everything will fit here. Yeah. Okay, sine theta, we got it. So then the distance OB should be equal to L cos theta. So this will be 1 minus sine square theta. So root 5 L by 3. This is what he's asking, answer. When the NB moves a distance of root 5L by 3, the end A will lose contact. And this is what happens. See, we thought like, okay, the ender will touch the O, but it will not happen practically. There's a very important data. Till now, nothing there in advance of this kind. So possibility of asking. But I think this, rather than numerical, no, it's a theoretical idea. How to calculate angular acceleration. So from omega, differentiate further, you'll get the angular acceleration. I'm just wanted to cover different aspects of the problem. No? So that's why I just picked up this one. Everyone knows how to get this omega. So do remember, if they ask you for thing angular acceleration or any of these things, no, so you can focus here. So this alpha is very important. If you know alpha, can you calculate the acceleration of point B or acceleration of point A? I think by considering question, previous problem, take help of the previous problem. How to calculate velocities, we know. How to calculate the speed of the N, B and A, that we know, because we know omega. And since the rod is rotating about point P, we'll get it. Now you have to ask one very beautiful question. Sir, okay, here you are bringing this omega. Where is this alpha? Can you show this alpha? Is it about C or about P? Anybody wants to answer? This alpha is about P or about center of mass? This omega is what I'm showing here. So what about this alpha, sir? Where you are going to show this alpha? Is it alpha about point P? Nothing wrong thinking like this, because we something will learn, no, with this one. Anybody? Alpha is about P or about C? About C only. This is about center of mass. Better write it. Say why to accept blindly things. Then, sir, what about omega? This is the, in fact, the rod is rotating. This will be much easier to determine here. The omega about this particular point. It will rotate about C only, angular acceleration. It is not instantaneous center for acceleration. It's only instantaneous center for only the velocity. Getting this? Huh?
For acceleration also, it's the instantaneous center, no, sir.
No, 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 no. Whose side? Whose side? The point P what? It's instantaneous center only for velocity. No, it need not be for instantaneous center for acceleration. The reason for that, I'll tell you. So in the rolling motion, so if a body rolls, no, let's have some. So pure rolling. What is the velocity? So v equal to r omega. Let this be r. Okay, I agree this. This will be. Now what is the velocity? This what instant center is what I'm defining. So it will have v and r omega. It will have omega square r. No, velocity of point P will be zero. Acceleration of point P will be non-zero. So how come this will become instantaneous center here? Then if it is having acceleration, let's get into this one. A, this alpha. So then this is what this point P is not instant center. Only acceleration of point P along x-axis will be zero. Because of that, we are writing R alpha. Am I right? Then, sir, is there any point on rigid body where acceleration will be zero? As we can search it. So look at this one. Omega square R. This will also have angular. Omega square R will be there. So what is the acceleration of point P? In fact, non-zero. But acceleration of point P along x-axis is zero. Because of that, we are able to write. Am I right? Then can we search a point on rigid body where acceleration will be zero? So you look at, let's take this point. Let's see that one. So this is having A, this having R alpha, then centripetal acceleration, omega square R. I think not possible here, no? Then what about here? This is A, this is R alpha. I think here there's a possibility is there. Huh? There's a possibility is there. So component of here not possible. Huh? Here there's a possibility there. So, somewhere in this region, S, here is what the acceleration of this particular point will be zero. So this cannot be instantaneous center. No, that's what the basic idea here. No? Of course, we don't go for instant center for acceleration. May not be needed also, but in applications are there. Our syllabus we confined only for with respect to velocity only. This acceleration of point P now can be zero. So there's a point P, no? So call this is say some Q. AQ will be zero. Net acceleration of point Q will be zero. Component of component of linear acceleration and tangential acceleration can be nullified, and the component of this can balance this. So try to check it. So in this quarter it is possible. Huh? What is omega? Omega is d theta by dt, no? So why we should, what is theta? We define theta here, no? The rod rotates about this particular point here, no? So you look at omega, this you try to think here. So again, once again, I'll reminding you, the instant center is what for our convenient to minimize mathematics, we have brought it. If you stand at point P, then what happens? The rod will appear rotating about this point. If you stand here, no, so d theta by dt is what omega. So don't get confused. So the rolling motion, same thing. There are two frames are there. You stand on the ground. All parts, all bodies are rotating about center of mass, and center of mass is moving horizontally. If you come and stand at point P, then all points on rigid body will rotate about instant center. The similar idea is what here also should come. If you stand here, you see only rotatory motion. If you stand here, you see both translative as well as rotatory motion for the center of mass. This is what in books what happened, we are bothered more about omega. No, we are thinking in terms of that. The similarly here, you stand here, what you see that you nothing instant center. No, what you say, center of mass moving horizontally, all points are rotating about center of mass. That's all. Finish over. You come at standard point P, then everything will rotate within same angular velocity omega. That's the idea there. Okay, we'll take this one here.